Castaway this week describes himself as a collection of water, calcium, and organic molecules. Using only this modest equipment, he's become a foremost astronomer, a very successful author, and a celebrated popularizer of science. It's Carl Sagan. Now, Carl, does music mean a lot to you?
Yes, I'm deeply attracted to music and get a kind of dependency withdrawal symptom when I'm away from it too long.
Have you any skill yourself as a musician?
I would say not, although I did play piano for 10 years until I was able to escape from home and be on my own.
Do you sing?
No, except in the shower.
Oh, naturally. Just 8 discs to choose for the island. Did you find it a hard task?
Yes, it's always difficult to select from an enormous range, only a few items. And I'm not sure that I wouldn't get terribly bored with any selection of 8, but it was interesting to try to choose.
What do we start with?
I'm interested in starting with a piece by Vangelis Papathanasiou, which by accident we've also used in the Cosmos television series. It's called Heaven and Hell.
Heaven and Hell by Vangelis with the composer at the synthesizer. Whereabouts in the United States do you come from?
Well, I was born in Brooklyn, New York. I teach at Cornell University, which is also in New York State, but I've been in California for the last, almost 3 years. I'll be going back to Cornell shortly.
Were you one of several children?
Yes, I have a sister 7 years younger.
Do you remember when you first began to be interested in astronomy?
I do very vividly. I was a small child, 5 or so, and even with an early bedtime, in winter you could occasionally see the stars. Cities were not as polluted then as now. And they seemed to me interesting, strange, remote, different from the neighborhood that I knew reasonably well. And I asked people, older children, adults, what the stars were, and they said, they're lights in the sky, kid. Well, I could tell there were lights in the sky, but it seemed to me there had to be some deeper explanation. It seemed to me unlikely that there were just little lights, lamps hanging from the sky. Who put them there? What for? And so when I got my first library card, I fairly breathlessly asked the librarian for a book on stars, and she gave me one which was about people named Clark Gable and Jean Harlow. And I explained that wasn't what I wanted, and after some confusion I got the book that I did want and turned the pages of this, easy children's book, and finally came to what I had been looking for, an astonishing statement that the stars were just like the sun, except immensely far away, that the sun was a star, but just very close. And I couldn't tell how close the sun was or how far you'd have to move it to make it as dim as a star, but I could tell that was a very big distance, and suddenly the scale of the universe opened up for me, a very powerful emotional experience, which I'm still engaged in.
You were only 16 when you entered the University of Chicago. I presume you'd taken a scholarship. Why Chicago? Was it the university of your choice?
Oh, yes, very much. I had applied to a number of institutions and been accepted, but Chicago sent a brochure called If You Want an Education. And the brochure went something like this. It said, if you want a school in which sports are a major consideration, and there's a picture of football players battering each other, don't come to the University of Chicago. Turn the page. If you want a school in which religious activities are a major part of what we do, there are people in pews, don't come to the University of Chicago. If you want a school in which fraternity and sorority life is a major thing, don't come to the University of Chicago. You got about halfway through the book, and it said, on one whole page, it said, but if you want an education, come to the University of Chicago. And it was the only university that advertised itself as providing an education. And that was what I wanted, and it certainly did provide.
Well, obviously there were other activities. What were you interested in apart from astronomy and astrophysics?
Well, I was very active in basketball and table tennis and meeting members of the opposite sex. And
all those things that Chicago said it didn't provide. You took your PhD there and left to go to Berkeley as a research fellow. What was your project?
When you get a PhD, there's always an enormous amount of topics that you didn't have time to complete, to pursue, and so there were a great many things that I did at Berkeley, but my doctoral thesis was mainly on the atmosphere of the planet Venus, in an attempt to explain the apparently high surface temperature of Venus through what's called the greenhouse effect, the trapping of infrared radiation by this massive carbon dioxide and water atmosphere. And I was fortunate enough to have been successful in the sense that subsequent space vehicle explorations of Venus have made a reasonably plausible case that it's a greenhouse effect that keeps the surface hot, and that the surface is in fact hot.
Well,
it's a very different place from the Earth.
Then you followed with a spell at Stanford University School of Medicine, studying the origins of life.
Yes, that's
You were really
true.
taking a thorough background in your subject.
Well, I was always interested in that question and had, even as an undergraduate, spent summers working in biology and genetics to try to provide some background in that field.
Then Harvard, the Smithsonian Observatory, and finally you settled down at Cornell in 1968. What was your assignment there?
I'm a professor of astronomy and space sciences, and I also direct the laboratory laboratory, I guess you say, for planetary studies. And we're engaged in a fairly wide range of investigations of the nature of the surfaces and atmospheres of the other planets and their moons, largely using unmanned space vehicles, which are trickling out through the solar system in all directions at the present time.
Was it the first laboratory of its kind?
No, I would not say so, but certainly one of the first.
Let's have your second record. What's that to be?
Well, it's the fairly well-known Canon by Pachelbel.
Canon in D by Pachelbel, Neville Mariner, and the Academy of St. Martin's in the Field. I presume the laboratory was tied up with NASA.
Yes, all of the unmanned space vehicle, and manned activities in the United States are done by the National Aeronautics and Space Administration, and they have had, despite extreme budgetary restrictions, just success after spectacular success in exploring all the planets known to the ancients, from Mercury to Saturn.
You were opposed to the moon landings.
Well, I was opposed to attributing them to science. I was perfectly happy if they were considered political or economic or historical or beat the Russians or whatever they were, but they were not fundamentally scientific. President Kennedy said he was going to put a man on the moon and bring him back safely by the end of the decade. He did not say he was going to discover the origin of the moon by the end of the decade. And the amount of money spent on Apollo may well have been an excellent investment, but it was not primarily a scientific activity. Mm-hmm. So I was opposed to beginning the Apollo program on grounds that would be attributed to science. And I was also opposed, somewhat paradoxically, to ending the Apollo program, because after this enormous initial investment had been made, there was a splendid system for exploring the moon. And instead, because it was only to show that we could do it, we stopped. As a very ironical and clear demonstration of this, the last man to land on the moon was the first scientist to land on the moon.
That's a rather cynical remark, yeah. Now, you worked, of course, on a number of the unmanned space probes. The pictures that came back of the surface of Mars were incredible and very exciting.
Yes, I think so, too.
And machines up there have been digging holes, which seems uncanny.
Well, we have done the first modest engineering works on another world. We've dug little trenches in the Martian soil to examine the composition of the soil and see if there's any obvious signs of life. The missions we're talking about are called Viking, and they landed, two of them in 1976, each accompanied by its own orbiting vehicle, which was overhead in the Martian sky. And these were the first spacecraft to land on Mars, the first spacecraft to survive on another planet for more than an hour or so, and represent, in my mind, a critical moment in human history, a very significant transition from being locked on the Earth and being able to go to other planets.
And you've now mapped the surface of Venus.
The surface of Venus has been mapped very crudely by ground-based and space orbital radar. But much more detailed mapping can be done by a devoted space vehicle in orbit around Venus, and I very much hope that such a mission will be authorized in the near future. It has not yet been.
Now, what about Saturn?
Well, the most recent explorations have been by two spacecrafts called Voyager 1 and Voyager 2, which were launched in late summer of 1977. And the two spacecraft, one behind the other, flew by Jupiter and its rings, which in fact the spacecraft discovered, and its moons, and then were accelerated by Jupiter's gravity to an encounter with Saturn. The Voyager 1 encounter happened last November. The Voyager 2 encounter with Saturn will happen this coming August. Voyager 1 is then accelerated out of the solar system altogether. Voyager 2 will go on to make the first look at the planet Uranus before it also is ejected from the solar system in 1985.
Now, what about the space shuttle?
Well, it's a transportation system, and it's a device to get whatever you want up there. And so it is not primarily a scientific instrument. It has major military purposes, at least some of which I support. I believe that military reconnaissance satellites are stabilizing, that if no nation can make major troop movements without other nations knowing about it, that is good for everybody. Mm-hmm. Also, it'll be involved in communication satellites, which have worked a revolution in technology. You can dial Japan direct. Meteorological satellites, which are doing wonders in helping to forecast the weather. Earth resources satellites, which monitor the health of crops and potential mineral resources for prospecting and so on.
But sending men up there is fairly pointless.
Well, I believe that for the same investment of money, machines can do a better job than people for any of the tasks we're talking about. But that is not the direction in which we're going. And the idea of shuttle is that we'll be able to have a reusable launch vehicle, so you don't throw it away after each use, which is what we've been doing so far, and there are good economic reasons for that. It is, however, the only system which we will have available for launching scientific satellites and probes to other planets. So to that extent, it is a scientific mission, but it's not primarily scientific.
Your third record?
As a change of pace, a piece in the jazz idiom by Roy Buchanan called Fly Nightbird.
Fly Nightbird, composed and played by Roy Buchanan. Now, Carl, we're chipping away in search of knowledge at one or two near neighbors in space. But let me quote you once again. We live on an insignificant planet of a humdrum star, tucked away in some forgotten corner of a universe in which there are more galaxies than people. It's going to take a long time to get all that sorted out, isn't it?
Yes, and a good thing, too. Give us something to do.
Do you believe it would be presumption to think that only on Earth is there intelligent life?
I do. I think it's a presumption in two different respects. One, the conceit that we are especially intelligent, and two, that there is none elsewhere.
Do you think life on Earth is intelligent enough to stop blowing itself up before it's investigated other planets?
That's a difficult and tricky question. There's no doubt that we have the capability to destroy our civilization and perhaps our species through the proliferation of nuclear weapons. At the same time, it's also clear that we have an enormous compassion for others and capability to do good and to act wisely. And the tension between these two forces, which go deep into our revolutionary past, is the major issue that faces us in this time, I believe.
It's been said about you, you've written something like 300 scientific papers, written in scientific language for fellow scientists, and it's been said that you're too excited by your subject to undertake the slow, painstaking collection of data, which is usual. You want to put your ideas out first, to be shot down if necessary.
Well, I certainly have spent a great deal of time in the collection of data. Space vehicle missions often take 6 to 10 years from conception to actually acquiring the data, so you'll have to put the question to whatever anonymous source made that remark. But I very much feel that it's important to put scientific results out before the public in a timely manner because, first of all, the public is tremendously interested in the results, and secondly, because the public pays for this sort of science. And if we scientists expect the public to continue to support what we're doing, I think it's reasonably urgent that the public understand what we're about.
Right. Back to music.
I'd like to play a portion of Dmitri Shostakovich's 11th Symphony.
An excerpt from the Shostakovich Symphony No. 11, the Houston Symphony Orchestra conducted by Leopold Stokowski. What does that music mean to you, Carl?
Well, it speaks to me. I feel strongly about it, but I think if it were possible to say in detail, in words, what this was about, it would not have been necessary to write the music. I think the music speaks on quite a different level than words do.
Now, as you've intimated, you believe in the popularization of science. You've written a number of scientific books for that uninstructed person known as the general reader. What was the first popular book?
Well, in 1966, I did a book which was at least semi-popular with a Soviet colleague, I.S. Shklovsky, called Intelligent Life in the Universe. And it was enormous fun, both because of the collaboration. We had never actually met until long after the book came out. It was a collaboration by mail. And also because I discovered how much pleasure there was in trying to popularize science. So from time to time since then, I've tried to do some.
The Dragon of Eden, that won you a Pulitzer Prize. What's that about? I haven't read that.
The Dragons of Eden is subtitled Speculations on the Evolution of Human Intelligence, and it's about how we got to be human. something about the connection between our minds and our brains, and about the evolution of our brains from very early times, from fish and reptiles and non-human primates to ourselves.
And another more recent book, which we'll talk about in a minute. On one of the space probes, you sent out a disc, or there was sent out a disc, I believe you had a hand in it, of all sorts of music, speech, and sounds, in the hope that someday it might fall into the hands of the scientific-minded from another planet.
The hands or equivalent organs.
Yes.
Well, these are the Voyager spacecraft that we talked about before that have done this spectacular exploration of the Jupiter and Saturn systems. And due essentially to a quirk in celestial mechanics, these spacecraft will leave the solar system forever. Their transmitters will be dead. They will not be calling attention to themselves. But in the space between the stars, there's very little matter, and things tend to be preserved extremely well. The estimated lifetime of these spacecraft is about 1,000 million years. So long after the British Isles, say, or North America are gone by the geological processes on Earth, these spacecraft will be still pristine in the dark between the stars. Therefore, we thought there was, over 1,000 million years, some chance that some other species of spacefaring civilization might come upon this ancient, derelict, primitive ship and heave to and wonder who had made it. So attached to each spacecraft is a phonograph record, a metal disc with instructions for use written in what we hope is clear scientific language on the cover, and a cartridge and stylus. We assume if they can find us in the dark between the stars, they'll be able to figure out how to amplify the sounds. And on the disc are greetings of various sorts. We have 116 pictures encoded in digital form with instructions about how to reconstruct the pictures. Greetings in 60 human and 1 whale language, which there's no chance they'll understand. A sound essay on the evolution of the Earth. And perhaps most relevant to us, an hour and a half of what the New York Times called Earth's greatest hits, in the hope that music would convey something more about us than just our science and technology would.
That was an interesting musical exercise, to choose something that would still be fully appreciated in 1,000 million years.
By creatures very different from us. It may be an impossible task, but we thought it was interesting to try. It was certainly inexpensive, and I think there's something tremendously hopeful about us sending greetings to creatures so far away in time and space that we could never hear anything back from them.
Your next record?
My next record is, in fact, one of the pieces that was included on the Voyager interstellar record, a piece for a Japanese wind instrument called a shakuhachi. The piece is called Cranes in Their Nest.
A piece of Japanese music, Cranes in Their Nest. In the past, there have been a number of spectacular television popularizations of major subjects: Kenneth Clark's Civilization, Bronowski's The Ascent of Man, Attenborough on Natural History. Now you've tackled one, a 13-part serial called Cosmos. First, what does the title mean? What is Cosmos?
Cosmos is a Greek word invented in about the 6th century BC, which refers to the order and elegance of the universe. Not just the universe, but the way in which it is constructed.
What terms of reference did you set yourself for the series?
Well, one of our principal objectives was to convey the idea that science is accessible to a general audience, that it's fun, that it's exhilarating, that it's a delight. And given the entire cosmos to play with, we certainly were able to pick and choose what to discuss. It is largely, but by no means wholly, oriented towards astronomy. We talk about the history of astronomical ideas, about the space vehicle exploration of the planets, with lots of the pictures that we were talking about earlier in the program, about galaxies, pulsars, quasars, the possibility of life elsewhere, the grand cosmological questions about the origin and nature and fate of the universe, but also a wide range of other topics, including Champollion's decryption of Egyptian hieroglyphics, a stunning computer animation of how the master molecule of life, DNA, works, and a reconstruction that I'm very pleased with of the great million-volume library of Alexandria that was put to the torch by a mob in the 5th century A.D.
Is there enough evidence to have built that reasonably factually?
Yes, there's a fairly good set of scholarly evidence on what the library and its attached research center, the Serapeum, were about. We had to take some liberties where we did not know what it was about. And we built the thing using a stunning new technique called Magicam, in which, in effect, I am shrunk down to about 1 inch in height and wander through this detailed model with all the shadows falling correctly. And the thing has been so successful that the Egyptian Tourist Bureau has been, I understand, inundated with requests about how to visit it.
How long did it take to make the series?
Cosmos took something over 3 years to do and was something like 2 years in actual production, and was a very grueling task because we were concerned, on the one hand, to get the science right, even things that we weren't specifically talking about. We wanted sophisticated viewers to not see any contradictions with what we knew. On the other hand, we wanted it to be immensely accessible to a general audience, and that combination took some work.
It's an international production, of course.
It is, and the BBC has been one of our co-producers.
15 billion years of cosmic evolution in 13 hours. It's a tall order.
Yes, we certainly can't show it all, but we've at least hit the highlights.
Another record, number 6 we got to.
This is part of another piece by Vangelis Papathanasiou on a synthesizer called Alpha.
Vangelis, again at the synthesizer, playing Alpha. Now, these Vangelis tunes are from the soundtrack of Cosmos.
Yes, we made an effort to be very ecumenical in the music for Cosmos, and we seem to have been successful. An enormous amount of mail talked to us about the music.
And, of course, you've had a ball. You've put in all your favorites.
Well, I certainly had a chance to put in some of my favorites, but many of the pieces were, almost all of them, chosen because they seemed appropriate for the Cosmos series, and all of the music that is being played in this program has been used in Cosmos, and a special record called The Music of Cosmos is just coming out. We tried in Cosmos to appeal not just to the mind, but to the heart, and music plays a very important role in that, of course.
And there's a book to go with it, as one might expect, a big, glossy book with hundreds of color pictures. Which sequences in the series pleased you most?
Well, I must say that the series far exceeded my fondest expectations before I began. Some sequences were just so much better than I had, at the very earliest stages, imagined. For example, an extremely brilliant computer scientist named James Blinn constructed a sequence on the mechanism by which DNA, nucleic acid that is at the heart of life on Earth, works. It's never been done before. Not only do we see where all the atoms are, 30,000 atoms all in the right position, but these molecules are kind of molecular machines. They articulate, they do things, they reproduce themselves, they correct any errors that they've made. And we see the mechanism of operation at the heart of life. And it's done in just a breathtaking way. And likewise, the simulation of the Great Library of Alexandria that I talked about, I think is stunning. Some of the historical reconstructions, for example, of the life of the 16th century mystic Johannes Kepler, who was also the father of much of modern astronomy, was done, I think, in a very appealing way.
Now, after this, well, anything at Cornell is going to be a bit of an anticlimax.
No, not at all, because science is so exciting and compelling that as fun as all this was, doing real science is still more fun, in my opinion.
Record number 7.
Number 7 is an exquisite performance by Arthur Grumio of one movement of the Bach Partita number 3 for unaccompanied violin.
Arthur Grumio playing Gavotte in Rondo from the Bach Partita number 3 in E major. How good will you be as a castaway? Could you look after yourself? Are you a practical man?
I think I would probably be a spectacular failure as a castaway, but it'd be fun to give it a try.
Have you any hobbies that might be useful? Do you fish?
No, I don't think I've ever done it in my life.
No,
well, I've tried, but not successfully as a youngster.
Small boats?
No, not at all.
Would you try to get away?
I guess I would stay around for a while until I got completely bored and
Yes.
then try to take off if I
how
could.
how much boredom brings confidence. And we've got to your last record.
Yes. This is I think, exquisite piece of folk music from Bulgaria, where Eastern and Western traditions have merged. It's a shepherdess's song sung by Valia Balkanska.
A Bulgarian shepherdess song. If you could take only one disc out of the 8 you played us, which would it be?
I think it would have to be the Bach Unaccompanied Violin by Grumio.
Right. And one luxury to take with you, nothing of any practical use at all.
I think I would take as large a reflecting telescope as you would let me. You can spend the evenings very nicely looking at the stars.
Right. And one book, apart from the Bible and Shakespeare, which are already on the island.
The books of no other religion, just the Judeo-Christian tradition?
I'm afraid so. There just isn't room.
I guess then I would take the Boy Scout handbook in an effort to be as practical as I could.
Right. And thank you, Carl Sagan, for letting us hear your Desert Island Discs.
Thank you very much, Roy. I enjoyed it immensely.
Goodbye, everyone.
You've been listening to a download from the Desert Island Discs archive. For more downloads, please visit the Radio 4 website.